Hello, good morning, everyone. Okay, lately I stormed into some physics concepts. Please, I'm a physicist, yeah. So we do is still go back to that space. Thanks to God. Okay, so what do I stop that? We were looking into some concepts about vector and scalar quantity. So we know that vector quantity has both magnitude and direction. Take for instance, I'm driving from Kuje Abuja to Maraba. So that's a direction. I know I'm going to, but I can just stand up and begin to drive. So that's what we call distance. It does not have a specific direction, but displacement do. So most of the time when physicists stormed into the confusion of not knowing a vector from a scalar quantity, I'll normally say it is them not actually understanding the difference between distance and displacement. That's just the truth. Yes, because you say distance does not have a specific direction. That's a scalar quantity. So whenever you are deriving every derived quantity, because every base quantity, yes, which are the fundamental quantity, are all scalars. So when you be choose when you be trying to get the difference, only we are dealing with when you are dealing with derived quantity, because every fundamental quantity, sorry, are all scalars. But when you come to the derived quantities, which are independent, they are made up of combination of one or two of the fundamental quantity. When you are dealing with them, that is why you will now try to know whether it is scalar or it is scalar or vector quantity. Like I said, how do I know? Simple. Check the derivative component. Take for instance, we know that the major fundamental quantity, we are talking about Mechanism in this case, is Mechanism, because Mechanism is a study that helps us to see the measurable units of a physical quantity. However, for we to get the measurable unit of physical quantity, we have to know through their dimensional process, which is derivatives. Are you getting my point? So, like now, mass, length, time, they are fundamental. They are the three major core fundamental quantity. We also have current, electricity, that is current, which is in ampere. We have temperature, which is in Kelvin. We have luminous intensity. We have amount of substance. These are the seven major fundamental quantity. Now, when we come to derived quantity, majorly I will call them, sorry, I will coincide them under motion, because you can't be talking about displacement and distance without considering motion. So it's on the concept of motion, the strength of motion, we deal with uh, most of the derived quantity aside volume and area. And volume and area. So we're talking about distance and displacement. Now, if your distance is a scalar quantity because it does not have a direction, but displacement is a vector quantity because it has direction, and they are both in meter. Now, when we look at the second concept, velocity is displacement over time. So when you hear displacement on that concept, you know that it's a vector quantity. Now you can from there know the derivative means unit of measurement, because displacement is meter, distance is time. You apply mathematics, you have meter per second. So we'll now talk about acceleration, the same thing, changing velocity over time. We have seen what velocity is all about, meter per second square, divide by the next, meter per second, divide by the down second. You now give meter per second square. So you know that since there is velocity there, it's actually a vector quantity. When we now talk about force, mass times acceleration, the same thing. You have had acceleration, there's a vector quantity. So when you now go further, you talk about something like work, energy, power. Yes, work is force times distance. Yes, force times distance, which make it and it's in joules, because the person that found the concept of energy is actually an English physicist. His name is Joules. So it's in joules. So we are not deriving the units. It's in joules. And because there is distance in work, it's actually what? A scalar quantity. Actually, a scalar quantity. So we'll now go further. We'll now talk about something like energy. We have two forms of energy. And we also have two forms of force. We have the pulling force and we have the push force. In the pulling force, we have mass times gravity. Yes. And force is always in Newton, because defined by Isaac Newton. That's just it. So we also looked about energy itself. After we talk about energy, we have energy due to position of the body, like potential energy. So like now, that energy is something. Thank you. So it's mass times gravity times the height of the object. While we talk about energy due to motion, kinetic energy. But actually, energy is a scalar quantity. So we'll now consider power. Power is work over time. Yes. And work is actually a scalar quantity. So power is a scalar quantity. Yes. So, and it's also in what? It's in watts. It's in watts. I think I will stop at this place. I believe you will be able to get an insight over mechanics. All right, I'll be talking about temperature and electricity because there's relationship. A lot of relationship. Sorry, thermodynamics under heat and electricity. I'll be talking about that. There's much relationship. Just like how there's relationship between distance and displacement, vector and scalar quantity. Thank you for giving me your time and listening to the video.